Okay guys, so before this we have done with a few notation and definition of Laplace transform. Okay, where if I want to do a summary for our previous lesson, we have a few formula to find a Laplace transform for a function. For the first one, you will have if you have ft equal to a, where a is a constant, okay, a is a constant, then what you will have for your Laplace transformation fs, your fs will be a over s. Okay, this one is the Laplace transformation when you have your ft equal to constant. Okay, number 2, if you have your ft equal to polynomial t to the power of n, therefore you will have your Laplace transformation of ft fs equal to n factorial over s to the power of n plus 1. Okay, number 3, if you have your ft in the form of exponent at, where a is a constant, therefore you will have the transformation, the Laplace transformation of ft equal to 1 over s minus a. Okay, the fourth one, okay, if you have your ft equal to sine 80, okay, where a is a constant, therefore your fs will be a over s square plus a square. Okay, besides, if you have your ft equal to sine hyperbolic 80, your fs will be a over s square minus a square. Okay, next, what we learn next is, if you have your number 6, if you have your ft equal to cos 80, okay, therefore you will find your Laplace transformation is equal to s over s square plus a square. Okay, on the other hand, if you have your ft equal to cos hyperbolic 80, what you will have for your Laplace transformation will be s over s square minus a square. Okay, so this one is the 7 Laplace transformation formula. Then we have another 3. Okay, number 8, if you have your ft equal to unit step function u t minus d, therefore you will have your fs equal to exponent negative ds over s. Alright, number 9, if you have your ft equal to delta function t minus d, you will have your fs equal to exponent negative ds. And the last one, whenever you have your function ft equal to the function of delta t, your fs will always be equal to 1. So this one is what we learned before about the Laplace transformation. Okay, so today we will look into 2 properties of Laplace transformation. Okay, now let's have a look to our first properties of Laplace transform. So we call this property as a linear property. So let's look what linear property said. Okay, so if we have the Laplace transformation of the first function f1 and the Laplace transformation of the second function f2 exists, mean we have both Laplace transformation for f1 and f2. If we need to find the Laplace transformation of alpha times f1 plus with beta times f2, we actually can take out our alpha and beta out of the Laplace transformation. So what we just need to do is to find the Laplace transformation of f1 times with alpha and Laplace transformation of f2 times with beta. Okay, as a consequence of this property, we say that the operator Laplace has the linear property. Okay, this property named as a linear property. Okay, so let's see one example here. Okay, if you can see here, we have to find the Laplace transformation of 4t to the power of 2 minus with 20t plus with 25. Okay, so actually we can divide all of them accordingly to their Laplace transformation process. Okay, so we have the first one is the Laplace transformation of 4t square minus with the Laplace transformation of 20t plus with the Laplace transformation of 25. Then if you see here, 4 and 20 is a constant. Therefore, you can bring 4 and 20 out of the Laplace transformation process. So what you left here is you just need to find what is the Laplace transformation of t square. You need to times with 4 constant here. Then you need to find what is the Laplace transformation of t times with the constant 20 here, and the last one you plus with the Laplace transformation of 25. Therefore, we use the formula that we learned before, how to find the Laplace transformation of t to the power of 2. The formula is n squared, so your n here is 2. The formula is n factorial, so the n here is 2, so we have 2 factorial over with Sn plus 1. Therefore, you have S2 plus 1. Minus with 20 times with the Laplace transformation of t. Okay, where t is also a polynomial to the power of 1. Therefore, we have n factorial here, so our n here is 1. Therefore, we have 1 factorial over S1 plus 1 equal to S power of 2. And the Laplace transformation of constant is always a constant itself divided by S. Therefore, after you have done the process of differentiation, what you will get here? Okay, so you just need to settle or to simplify the Laplace transformation inside the bracket here. So when you simplify, you will have 2 factorial equal to 2, S2 plus 1 is equal to S to the power of 3. Here 1 factorial is equal to 1, S1 plus 1 is equal to S over S to the power of 2, and you have 25 over S here. Okay, so you just need to times the constant with the number in the bracket here. Okay, so it make you easy when you can take out the constant out from the Laplace transformation process. Okay, let's see the second example here. You need to find the Laplace transformation of gt, where the function gt is actually 4 exponent 2t minus 5 cos 2t. Okay, so you can separate both function here. Therefore, you have the Laplace transformation of 4 exponent 2t minus with Laplace transformation of 5 cos 2t. Okay, and you can see here you got 4 as a constant in front the exponent 2t, and you have 5 as a constant in front cos 2t. Okay, because they are just a constant, therefore you can bring it out from the Laplace transformation process. So what you left with is the Laplace transformation of exponent 2t, where we can use the formula that we learned before, as well as the Laplace transformation for cos 2t. Okay, we can use the formula to find cos that we learned before. So the Laplace transformation for exponent is actually 1 over s minus a. Here we can see that our a is equal to 2, therefore you have 1 over s minus 2 minus with 5. Then the Laplace transformation for cos is s over s squared plus a squared. Therefore your a here is 2, you have s over s squared plus 2 squared. Okay, then you just times the constant out here with the one in the bracket. What you left with the final answer is 4 over s minus 2 minus 5s over s squared plus 4. So this is the property that we call as linear property, where we can separate the Laplace transformation with operation plus and minus, and also bring out the constant out from the Laplace transformation process.